Okay, so here we have a question, and you can see it's there's a suitcase, and it says it's the shape of a cuboid. Just says, in case you weren't sure, it's a suitcase. You've got some right angles on each corner here. Diana has a walking stick that folds. The folded walking stick has a length of 60 centimeters. Diana wants to put the folded walking stick into the suitcase. Will the folded walking stick fit inside the suitcase? Well, first of all, you might think, well, no, because it's 45 across here. But remember, if you picture this, you can have, there is a longer corner to corner here, which slices right across the box like that. If you can imagine a cuboid and you go this way, and that's going to be longer than the width. So they're saying, is that going to be 60? Now, how we do this, you may or may not see this, is we would use 3D Pythagoras, because we don't, it's not 2D, because we actually need to think about it along the volume. So if we just picture, first of all, the triangle that we're trying to find, because we want, that's the first, this is the first triangle really, so the first triangle there, a triangle we need, so we need the hypotenuse of this right angle, but unfortunately at the moment we've only got the height of it, we've only got 30, we don't have the hypotenuse, and we don't have the base either. However, if you can imagine this cuboid, the flat part of it, so if I just change colour and show you that there is another triangle that can help us, and that is the one that goes along the bottom, because what that is, that shows us that there's like a 2D sort of flat on the bottom of the cuboid, and the hypotenuse of that one is actually the base of this one. So this is really about visualizing. So I'll stick with the red pen, and let's just try and then first of all we need the hypotenuse of this one. So to find that, you'll be using a squared plus b squared, so this is Pythagoras, equals c squared, and we're finding the hypotenuse, so it is that way round. So you'll be doing 45 squared plus 20 squared equals the hypotenuse squared, and then we'd work that out. If we want to sort of do this slightly neater on our calculator, we can all square it all in one go. If we could just put that all in your calculator, it just saves you having to retype it out again. So I'm just going to do that now. So if you do the square root first, hang on, I can't. 45 squared plus 20 squared. I've got that's 2425, and then if we square root that, square root's gone missing, that's strange. Should get a value of 5408. So C 5408 is C. So I'll just put that one away. So that's going to say that this line along here, 54.08, is my base of my other triangle, and now I have the base and the height, so I can do exactly the same to find the hypotenuse of that one. You can actually, if you get good at these 3D Pythagoras, you can actually do them in like one step. I'm only not doing that to sort of show you how it works. So then you'll end up doing that 54.08 squared plus 30 squared, and that will get my answer, my c squared, sorry. And then if you square root that to find c, so my square root's not working, so I'm just going to have to check quickly the answers here. You should get 57.66. Now, so if that's 57, you can see that this walking stick of 60 centimetres will not fit in. So you've done all the work here. Please remember to get the statement, the sort of statement mark, the conclusion, sorry, mark, because if you don't pick up on it, then you will just lose that mark straight away. So then you say, no, 57.66 is less than 60, therefore the stick will not fit. Okay, and that's it really. So so there is a way you can just do it all in one go. You might be able to see that, because obviously the answer to this is literally going straight into this. So you can do it all in one go really if you wanted to, but it's good. It is good to write it down just to make sure you're all right. And you can always draw on these diagrams. And if you're talking about a diagonal in a volume, it's quite often going to be 3D Pythagoras or 3D trigonometry. So yeah, I hope that's kind of helped you out. You don't see those very often, but I think that was a really nice question to show you 3D Pythagoras. Okay, thanks for listening.